Hi, friends. I am so excited. Can you believe what happened today? We landed on a freaking comet. You hear about that? And we also, opensource.net, have it running on a Mac and Linux and gave away a copy of Visual Studio to everyone. That's amazing. Open source developers can run Visual Studio, they can land on comets, and they can run on a Mac and Linux. I mean, what a fantastic day. And that's really just the beginning. I've got a lot of cool stuff to share with you folks, and I appreciate you hanging out with me today. As you saw with Skanska, the stuff that you can do with the cloud is getting completely amazing. It really helps you differentiate from the competition, and I'm going to show you even more, get lots and lots of demos, and try to put it into a larger context. I want to make it as actionable as possible. When I think about the cloud, I think about superpowers, and I think about things that took me weeks 10 years ago suddenly are taking me minutes. I used to scale out a cloud server over a weekend because I had to do it. I had to buy the machine, and I had to set up the load balancer. Now I do it at the command line, and it happens in seconds. I was trying to explain this to my kids because they love superpowers, and I tell them, like, I built this thing. And I come out of my office with the laptop, I built this thing, and my 6-year-old's like, I built this thing. How can I get my kids to think about this stuff and think about superpowers for what that means for developers? And I wanted my 6-year-old had this idea about building me a little cloud. Like, how are you going to build me this cloud? And he says, well, you know, the servers look like this, son. And he says, yeah, we have servers in the closet because I have my home server in my closet. So he came up with this idea. This is kind of silly, but let me show you something here. I'm going to connect and see if we can find out what my 6-year-old made. I figured that the only way to do it was to do it in Minecraft, because we bought them, but also because Minecraft gives little kids superpowers, especially when the internet works. So let's try that again. Oh no. Let's try and get some internet here. So my 6-year-old went and he built me a little cloud in Minecraft. I'm going to let the demo folks get that, or tether my cell phone to the machine here. The great thing about the cloud is you just keep doing it over and over again, expecting a different result. Well, that's disappointing. Let me try an alternate machine, because my 6-year-old would be very, very sad if we didn't spend at least some of Microsoft's time and money showing you what he built. So he went and he built this cloud server. There we go. And what we did was he built me 3 little servers down here with a switch, because Daddy's always concerned that we shouldn't turn off the servers. Thank you for the applause for the redstone there. And then I said, well, these are not big enough. These servers aren't big enough. And I said, you need to make me cloud servers. So we built a connection, a hybrid connection to the cloud here. Here's Azure. So we have a full Azure data center built entirely in Minecraft, set up with actual data flowing. So he was excited about having pulled that off with his friends, Glenn and Paul. So I wanted to show you that. But the reason that I wanted to show you that is the enthusiasm of that, the building blocks, the pieces that that gave him a sense of accomplishment. And he's 6, and I'm not, but I can suddenly take things like Salesforce or Office or PC or the .NET compiler as a service, and I can plug these things together, and suddenly I'm a full-stack integrator. You know, my son, we talk about full-stack developers. My son has gone from being a full-stack developer in Minecraft, and now I'm a full-stack integrator. And that sense of joy of building is what I want people to understand about why we're opening sourcing things and why the cloud is so exciting to me, and why the cloud extends what you have and does some really amazing stuff. So building for the cloud is the story that I want to tell you today. And I want to talk about basically 3 things, 3 classes of applications. We're going to talk about the modern web, the open web, and what that really means, because I've always said that I came to Microsoft to do open source, and we're doing it. We're making it happen. We're going to talk about connected services, this concept of connected services, taking software as a service kind of to the next level. And then we're going to talk about IoT and big data, the Internet of Things, and how this explosion of tiny devices causes an explosion of data, and how we're going to make sense of it all. And I'll try to show you as much code and demos and fun stuff as humanly possible. So the first thing we're going to focus on is the open web. Now this means HTML5 and CSS and JavaScript and things like that. But it also means Microsoft and Visual Studio tools joining the open web using the tools that people are using. So we're going to talk about the client side, and we're going to talk about the server side, because we need client-side build tools that other frameworks are using. Grunt, Gulp, NPM, Bower. We need modern clients that are going to have responsive design. We're going to have fast, fluid experiences. But then on the server side, we need a custom experience. We need a memory-optimized server-side CLR. So we'll talk about that. All of this is going to be fully cloud-enabled. So let's dive in and we'll take a look at what the modern and open web is. So here, I'm in Visual Studio 2015. And this is just a hello world, but I want to show you that when we say add new project, and we go into an ASP.NET application, you see ASP.NET 5 applications alongside ASP.NET 4 applications. And when I say I want an ASP.NET 5 starter web, you notice that these are grayed out because we've unified MVC and Web API and SignalR all into one framework. So you don't have to pick and choose. I'll actually show you some code about that. Over here on the side, thinking about things in the context of client-side, the idea of a client-side build is becoming more and more common. Minifying CSS, managing your JavaScript libraries. You can't just throw JavaScript in a scripts folder and expect for things to be okay. So we've actually got a formalization of that with this www-root folder. This is basically your static folder where the results of your client-side build goes. But it wouldn't really make sense for us to create tools when good tools already exist. So if you go under dependencies here, you can see that we've got full support for Grunt, Gulp, Bower, NPM inside Visual Studio. These are the open source tools that the open web uses, so there's no reason that we shouldn't be using that as well. You can see here that I've got some Bower. This is a package manager that brings in client-side frameworks. But one of the great things about Visual Studio that we always feel strongly about is if you can do something great in text, you should be able to do it great in the UI and move back and forth between them. So if I come over here and start typing Angular, we're actually searching Bower from here, getting IntelliSense at the entire experience, and then even bringing in versions and information like that. And if I hover over those, I'm getting information about where they came from, where that source came from, and even the ability to install packages directly from here. So this is not a glorified text editor. This is a complete environment that extends these popular open source tools, but does it in a way that makes it accessible for everybody. So I can take any one of these and go and say, open that home page or install that package. And then that immediately is reflected over here on the dependencies side. So I can add in Angular. Now I'll switch away from this Hello World example, and I'll switch over to the My Shuttle application. This is this example that Nicole was talking about. This is the business car management system. We've got a number of different sites here, the data model and the website. And this is using Grunt for its client-side build. And we've got a full IntelliSense inside of this, but what we want to show you is down here. Grunt and Gulp support inside of Visual Studio where I can actually see individual tasks, then run them. But it's not just about running them, it's about integrating them with your Visual Studio experience, because I might want JS Hint to bind to MS Build, because I want the Microsoft tools I've invested in to plug in cleanly into the open source tools that my developers are excited about. So now I can say, run JS Hint after that build, and that will happen in my application here. So let me go and I'll run this application. Moving from the client side to the server side a little bit. This is an Angular JS app, and this is running on ASP.NET 5. And I'm going to go ahead and log in here. So this is a modern app and responsive, and it's smartly designed. It is as any app should be. And this particular application is running with ASP.NET 5. But if we open up in the references here, we see that it's actually referencing 2 versions of ASP.NET because it's simultaneously building for either one, for the full .NET framework or for the server-optimized core framework simultaneously. Again, this experience here in the UI rather, is being reflected here in the code. So we have very clean JSON-based configuration. If I remove that, that node disappears. Now, that core framework, we're going to talk a little bit about how important that is, but the references dialog, that is part of NuGet. You've heard of NuGet before. It's package management for .NET. We're bringing in that framework itself as a NuGet, and rather than a check a box and the totality of the .NET framework comes over and then boom, there's the .NET framework, you just take the pieces you want. Even if you want to do something like serve static files, you have to opt in. Completely cloud optimized and locked down by default. You don't pay for anything from a memory perspective or a perspective if you don't want to. Now, if I go to the NuGet dialog, we've got a new NuGet dialog. It is modeless. It lets you bring in different versions from here. And that whole thing is significant because let's right-click on the project and go to Properties and take a look at this. There's the CLR that we know, and there's the core CLR. I can target different versions when I go and package this thing up. And where are those located? This is significant. I'm going to show you the references here are the same as the references there. NuGet packages are the new build artifact. So I can refer here to NuGet packages or also source. They're interchangeable. I could drop in MVC and start debugging directly into the source. But this point about the CLR, let's find out where that's located. Not a lot of keynotes that you see where people show you stuff like, let's get into the file system. But people want to see this because this is important. Everyone needs to understand this. There's the core CLR. I'm going to click on that. Now, take a moment and really drink this in. This is significant. This is the biggest thing since .NET. That's the CLR in a NuGet package, private and redistributable for my application. That means application A in the cloud can't affect existing application B. People are afraid to upgrade their .NET implementations because they're concerned that this app might break that if this depends on a certain version. You have your own private CLR. You'll be able, you like that? Took me a while, but I got you. You have your own private CLR. You should in the future be able to go up to GitHub, clone it, make a modification, and even have your own private build if you theoretically wanted to. What this is about is choice. Just like in that Minecraft, it's an open world, and there are no limitations to what you do, and that is so significant to be able to not have to be at the beck and call of IT who will not allow you to install a version of .NET on a server. You can take control of your experience. So check this out. Let's right-click again and look at the bin folder. Like, what's the build artifact? This is the bin folder for my application. It's empty. There's nothing in there. So while I'm doing this development experience, I want the full speed and power of .NET. I want the C# that I've been counting on for years. But my developers are talking about things like Node and dynamic languages. They want a refresh and go experience. So we're giving you both. We're giving you the ability to do in-memory compilation. You simply hit refresh, and the build step is there. People are used to hitting Control-Shift-B. Well, Control-Shift-B doesn't really do anything anymore. It just spell checks your code. The compilation happens that first time. You can pack it up and create DLLs if you want to. But I'm going to take this home page here, and let me go ahead and go to the home page. And this is in the home controller, this text here. We'll be silly here, and I'm going to go Control-Comma, and I'll go over to the home controller. There it is. Now, you'll notice in here a couple of things before I change that text. The home controller has no base class. So it's optional to have a base class. You don't necessarily have to derive from controller and drink in the entire thing. It's happening by convention. We've got no default constructor there on line 20. We've got built-in inversion of control, built-in dependency injection, and also the ability to plug in your own that is in the unified framework. Notice that we're not saying this is an MVC controller or a Web API controller. It's a controller in this unified world. Now, this text right now is not in a view. This is sitting in a controller. So I'm going to just hit save and come over here and hit refresh. And when I do that, we'll bring up the bin folder at the same time and see that compilation happen. Nothing is going to show up in bin. We're going to see the recompilation of the entire application. And we're going to try to get that down as fast as possible so people will be able to go refresh, refresh, refresh. So the full experience of a dynamic language and the full power of the .NET framework in a completely composable and flexible way. This is all using Roslyn. And again, can't stress enough, all open source and pretty amazing. So one of the things that happens when you start doing things in the open is this idea of innovation and opportunity. People can say, you know, I really like that piece, and I want that piece to plug into this piece over there. But then you find that, oh, well, this is an open source, and that's not really something I can do. I wish I could do it. I want people to understand that we're serious about open source, and that I think this is a huge opportunity for open source and .NET, and I wouldn't work here if I didn't think that it was. We can come up with ideas that are beyond what the originators of those ideas imagined. So I want to show you something completely new based on something kind of old. But let's just take a moment to review this new .NET ecosystem. That .NET Core side over there, .NET Core, ASP.NET 5, open source, ASP.NET 5 for Mac and Linux. All of this started kind of in the mid-2000s when we open sourced MVC. This year, we launched the .NET Foundation. We've open sourced Roslyn. Now we're making a commitment to a cross-platform .NET 5 core, updating the terms for licensing to MIT. Amazing stuff. Who better to talk about this than my good friend Miguel de Icaza from Xamarin? Hi, friend.
Hey, Scott. How's it going?
How are you?
Fine, fine.
It's so nice to be up here.
Yes.
Together. We did it. It actually happened.
Yes, it actually happened.
So it seems like the only thing to do would be to look at it and maybe you could take that code and do stuff with it.
Right. So for those of you that don't know, I've been working on the Mono project, which is a open source version of .NET for about 14 years. Mm-hmm. And Mono has great pieces, and it has a couple of gaps. And so this is a great announcement for us because we get a chance to essentially converge these two implementations, and we get a chance to have a better .NET and grow the .NET ecosystem. So yeah, let's go. Let's get here.
Take a look at this machine here, mm-hmm. And I took the liberty of logging in as you.
Oh,
I hope you don't mind, since we share passwords and things.
All right. Okay. All right, so this is a core foundation code that was just open source today. And I guess the first step is for us to make a fork so we can take a look. We work on our code base, and when we're done with this stuff, we submit a pull request to the .NET team. Right? That's how this works.
That's how it works. And I have to say, though, I was hoping you would be the first forker and the first pull request. But unfortunately, and I say this jokingly, this was published minutes ago.
Yes.
We have all, and this was not staged. I literally got a text about this a minute ago. Mm-hmm. We've already received, checked the test, and accepted a pull request from Adam Ralph in the community. He was.
That is unfortunate.
It is unfortunate.
It is unfortunate
that you did not get to do that.
But we're drinking coffee upstairs and celebrating. So I guess we're going to fork this guy, and we're going to fork it directly to the Mono project. We're going to make our changes there. We'll do our contributions there, and then we'll send a pull request to you guys. And yes, here's this guy that
he just
stole our thunder. He stole our thunder.
Yeah, it's awful.
But that's okay. That's okay.
So there's a bunch of great code in the Mono project, and like you said, you've been working on this for 14 years?
That's right, yes.
And some of it we thought was so cool that we put together a little project that I wanted to show you. Mm-hmm. So this is an announcement of something that we're working on, not as Microsoft, but just kind of a bunch of really excited people, called OmniSharp. You can go to omnisharp.net. We took a thing called nRefactory.
Right, so the story of that project is perhaps the largest .NET application that was written in 2001 was an IDE called Sharp Develop. So these guys were the first early adopters of Windows Forms, and they decided to build a whole IDE entirely in C#. And then that ID evolved over the years, and we ported it to Linux and to the Mac. And we called it monodevelop. And then they kind of forked, and we said, well, how can we share a lot of the code between these two? And they extracted pieces that were not tied to Windows or Mac or Linux. And one of those pieces is called nrefactory, and it provides things for changing your code, code completion, refactoring things, renaming things, applying rules, and so on. And these became the foundation for this OmniSharp technology.
Right. So some very enterprising people, along with myself and Syed from Microsoft, got together and put this together. So check this out. Here's what we've got going. Here is clearly a superior editor to anything that you've ever used. This is Sublime.
It's an editor for hipsters.
Hipster editor. And I'm in Sublime here, and I can start typing. And rather than just autocomplete, I just got IntelliSense for C# in Sublime on a Mac, looking at an ASP.NET 5 application.
Yes.
So at this point, I just drop the mic and I just go like that.
Well,
you can't possibly beat that.
Kind of. I mean, and it's also all powered by Mono. But I think that real programmers, this is well known in the industry, really use Emacs. People that really know their Lisp, or you run your commands, but essentially the same functionality that you just showed.
In text mode.
In text mode, yes, yes. Well, it's not text mode. It's a way of life.
It's beautiful.
Yes, it is a way of life.
So not only do we have Emacs and Sublime, we have Vim, we have Atom, we have brackets. We have all the tools that you need to do this with this OmniSharp community project.
Right, and the idea is that the editors just speak to this external server.
Exactly.
It's running a tiny HTTP server that provides all the nrefactory services, so renaming, code completion. I mean, you got it there. Add references, fix
So
issues.
those are externalized, and that can be taken. And this is an example where they took a piece of this that was useful, a piece of that, they brought it all together, and they're making it happen. So on this Mac right now, I can actually open up a terminal, and I can make this really big, and say KVM list, and we can see the different versions of the ASP.NET 5 runtime running on.
Oh, nice.
Wow, isn't that great?
Yes, 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 yes.
So the other thing that I can potentially do here in Sublime, and this is the exact same application, the My Shuttle application. This is not a Hello World application.
This is the one that you showed earlier today?
This is the one we're showing earlier today, sitting on the Mac. And I'm going to go and use a command prompt, and these are some commands from within Sublime to go and launch that actual ASP.NET project.
I haven't actually seen this.
You haven't seen this? No? Because they got to make it a surprise. And that's the same app on this machine, developed in Sublime, running on a Mac, using a thing called Kestrel, which is a web server that we're shipping for cross-platform.
Nice.
You like that?
Nice. So
there is some really, really amazing stuff going on right now. You can check out even more fun stuff at microsoft.github.io. Do you feel you have enough things to do today now?
Yes. We're going to go back and start looking at the code and making some changes.
And bring them back, and we'll put together some great stuff.
Yeah, thank you so much, Scott, and everybody at Microsoft that made this happen.
Thanks, friend.
Goodbye. Nice. Whoa.
Oh.
Hey, how you doing?
I would hate for that fork to go unused if you had fallen there and died. All right. So let's shift a little bit from the development. I've made this application, whether I made it with Visual Studio on Windows, or I made it in Sublime on Mac, or Ubuntu with Emacs. I've made that, and now I'm going to put that up into Azure. All right, now, you know, the Azure is the cloud platform. They've got 19 regions in Azure as of today. It's more than anyone else. One of the things that's important to point out about Azure, though, is what you can build on top of it. And we hear about IaaS and PaaS and SaaS, and it gets very confusing to me. And this is how I decided to look at it, since we're doing a car system here. IaaS is like a car. You can go anywhere you want, you can do anything you want, but you have to maintain the car. It is your car, okay? That is infrastructure as a service. A rental car is like platform as a service. You can do limited things, go limited places, but ultimately the car gets maintained by someone else. That's like Azure websites, which I'm using to run this particular application. But there's another level above that, and I'm going to use this after I get off stage, because I'm going to go to the airport in probably a taxi. Someone will go in a limo, though, and it's going to be totally managed. I don't have to think about anything. That's when you've got software as a service, or even perhaps service as a service. This idea of a higher level, when you've got things like Hadoop in Azure and HD Insight, our implementation of that. You have Office 365 or Salesforce. This is a much higher level of attention and management. I don't have to think about running updates on the operating system. I simply use the service. So you get to pick your level of comfort there. So let's take a look at a couple of cool things that we're doing with websites and in the cloud. So we'll switch over. Oops. I'm going to have to log back in here. We're going to go into the Ibiza portal. This is the Azure Preview portal right now. And pardon me. Let's all watch me put my password in there. Even better that I did it correctly. And what I'm going to do is I'm going to show you some of the things we've got. We've got the East US resource group wherein my website is. Okay? So here is the My Shuttle website. Now there's a great feature in websites that I use called deployment slots. And deployment slots, in this case I have 3, allow you to have dev, test, and staging within a website. So I can have staging running, deploy to it, and then swap them. That's cool. This is the kind of thing where myself, as kind of an old-timer, I think like that's a whole page of my resume now that I have to get rid of. They've reduced that page of my resume to a button. The configuring of the virtual IPs and the reconfiguring of the load balancer, that was a whole page. That was my life, and now it's just push a button and then complain if it takes takes more than 10 seconds. But what's really interesting is this new feature I want to share with you that is called testing in production. And this is really cool. You don't necessarily want to swap immediately. I want to see if staging can handle it. I want to do maybe some A/B testing. I want to put staging in and then bring it up slow. I might want to script it. What if I could go and say, I want this staging slot to take 10% of the traffic and then have production take 90%? And then slowly move that. And if it looks like that rollout's not going to work, then back off. All of that, very easy to do inside of the portal, or I can script it and ramp it up over time. So testing in production is another way to think about how we've abstracted the complexity of running a production website away from you. Now, this is the My Shuttle site. One of the other things that's running under My Shuttle is a web job, because when a driver is going to take the invoice and then submit that, they're going to put that into an Azure queue, and it's going to go into Salesforce and off into the world. There is a web job running in the background that's going to do that work for me. So this web job is here. It's like a background process that's running. It can listen on a queue. But I can also manage that inside of Azure. So I can come over here, and I could say, add a new web job project, and we've got integration inside of Visual Studio. So you're going to see this ongoing theme where I have a great experience in the portal, I have a great experience in the command line. All of this can be scripted, whether it be cross-platform or in PowerShell, and all of this has a great experience inside of Visual Studio. So not only can I come in here and set up my new web job and manage it, I can also go over to the Server Explorer, and you can see that my website's files and my web jobs can be managed here and even interactively debugged. So from here, let's take a look at some of that code. I'm going to go over to post-ride, and then I'm going to step back for a second. I'm going to leave this demo and talk about connected services and how it's going to plug into this web shop and why it's so meaningful. So connected services are cloud-based APIs that are up in the cloud. This is building on what we talked about before. Now we're talking about connected services. Devs can spend a lot of time learning the surface area, dealing with things like WSDL and Waddle and Swagger and $ metadata and all that kind of stuff. So again, thinking about leveling up, add reference, add service reference, add connected service, setting up services for modern authentication schemes like OAuth, and adding those in so that you're optimizing the consumption experience, but also putting the experience for how that developer interacts with the service in the hands of the creator of the service. And we can do all of that with T4 scaffolding such that the user has the ability to consume those services, but then modify them if, in fact, they need to. So we've got connected services today with like Salesforce and Office 365 that I'll show you, but you'll be able to put your services inside of this as well, and I'll show you how developer can have that great experience. So what I'm going to do is go back exactly where we were, and we're going to take this, this web job, and within this, when we have posted a ride, okay, here on line 49, we've posted a ride, we're going to go and we're going to create an invoice, put that on a queue, and we're going to add that person to our Salesforce backend. So we're keeping that context. So here I'm plugging two things together, and I'm going to peek in on that with peek invoice. You can see where I put that in on the queue, all right? And then from there, once the web job runs to go and process that queue message, we're going to stick the invoice into SharePoint. So it's an orchestration experience. And what's great about it is that when I added that reference, all I had to do was say, add connected service. You see how it's all part of that reference experience. We've got Azure Mobile Services, easy access to Azure Storage, Office 365 in the example where I upload to SharePoint, and programmatic access to Salesforce. So now, let's take a look at this application that I've got, and I'm going to bring up this, let me see, I'm going to bring up this app here. There we go. And my friend here is going to join me. I keep him around anytime anything that's, if anything needs to be filmed. So, can you see that okay? All right, so we're going to go and we're going to say, start service. So this is my Cordova application that we saw a little bit before. So we're driving and we're driving, start. Okay? And when I hit finish, now we've gone somewhere. Apparently we've just driven around the block, which is exciting for us. And then I'm going to go here and do my signature. This is my official signature. I put this on most of my checks. And when I hit accept, this is going to go from the Cordova application up to the cloud. It's going to show up in the queue. The web job is going to run. And then it's going to upload into SharePoint. So I should find then the contacts inside of Salesforce and in SharePoint. So we'll come back over to this machine here where we've got SharePoint. And here's my MyShuttleBiz. And I'm going to click on Invoices. And we'll sort by, here we go, Modified. You can see just a few seconds ago, an invoice showed up. So now we click on that invoice. We can see I went from here to here, which is where we are. Up, and there's my signature. So this is one of those experiences that I think that only developers can understand, where you accomplish something like this, and you're in your cube, and you go, and no one else in the cube farm cares that you've just done that. But this is the thing where I jump up and I run and I try to tell my 6-year-old that this, like, did you just, but he doesn't care. No one understands, like developers, how exciting it is to get an integration experience working like this. It's really, really exceptional, and it's fun. So we've got the mobile devices, and we've got all these cars out there, right, that are going to be driving around creating data. And the way that we're going to need to manage those is with IoT and big data. IoT, of course, is the Internet of Things. And big data is what happens when you put a bunch of tiny stuff on a whole lot of things and you start streaming data and capturing it over time. Huge amounts of data. So the Microsoft Data Platform is all of that. It is the relational, it is the non-relational. It's SQL in the cloud, it is DocumentDB, it's things like HBase, it's storage, it's HD Insight. You're going to capture that information. You're going to bring it in, and you're going to perhaps clean it up, bring it into a data store where you're then going to transform and analyze that data. You're going to bring it into Hadoop as a service and HD Insight. You're going to run stream analytics and maybe change the data as it moves through the system and clean it up, look for patterns. Apply machine learning and use languages like R to talk to this and ask it questions. And then at the end, when you have those data sets, visualize that and then make a decision about that. So I wanted to figure out how I could express this to you all. And the best idea was this idea of the Internet of Things. Now, I've got a board around here somewhere. Here it is. So this is a great little board here from GHI that's runs .NET Micro Framework. And this is the other thing that I love about being a .NET programmer is that I'm doing C# in 64K, and then I'm doing C# in 64 gigs. You know what I mean? It's like the complete thing. I'm writing phone apps in Xamarin. I'm making tiny apps on IoT. And I'm doing huge things in the cloud. This has gyroscopes and temperature and all the kinds of things that I want to explore. All these sensors. I'm going to plug this into a car, right? And then do something with it. So what can I do? Well, I don't have a car. I have this thing, and it's not even plugged in, which somehow makes the demo less impressive, doesn't it? But I do have this fake car, and I have an artist who knows how to draw fake cars. And what I can do is tell this fake car to generate some data, and we're going to plug this into Azure. And then I'll log back into my application here. And I'm going to go over to the alarms, and we're going to see what's happening with this car. And I can change the things that are happening with this car and put in high alerts. And this is automatically updating as we move around and make high alerts or low alerts, and this will refresh to see there it goes, all the little things that are going on inside of that car. And this is where the idea of big data hit for me. It's like, okay, well, that's a couple of records every second, plus location, and all that information, and it's all streaming into this system. But still, this is just a simulation. It was not quite enough. I'm going to show you how I got even more data and built even bigger stuff. But we generated a lot of data. So I'm going to switch over to this machine over here. And I've got 20 cores running in this HD Insight cluster, managing all this huge amounts of data that are coming in. And not only, again, to keep pushing this theme that I can do it in the portal, but let me switch over to Visual Studio. I can look at those clusters here. So I can see my Hadoop Hive database, my HD Insight Hive databases inside of Visual Studio, and then open those up, and then here's that trip data. Now, I needed a lot of data, because again, I only have this thing. But it turns out that the taxi data for New York is public. You can just go up and download it. So we downloaded 50 gigs of traffic data from the taxis, and then we dumped it into this system. And then we can go and look at that trip data, and I can look at those rows and see all of this stuff. But that's boring, because that's a lot of trip data from 2013, and that wasn't quite enough. But what I really want to do is run experiments on this. I've done the collection part. I want to do the storage, and then the analysis, and then the visualization. I want to move it through the entire experience. So let's zoom out of here. And let me show you what I made. This was a thing made in Power Map for Excel using that same data. So this is the taxi data from 2013. Now watch this. This is on the first day of the year, and those are the taxis moving around minute by minute. This is all done for real. We made this. This is what's so great. I try to explain this again to my 6-year-old. But I made that. And he's like, I've seen that before. I don't think you have. I don't think you understand what exactly that I've made here. It's amazing. So then I realized if I have all this data and all this information about how these cars are driving, I can finally prove a question that I have always wanted to know. I can apply machine learning to this question, and let's see if we can find out. Here's an ML workspace, and I'm going to go and find out if Guthrie is a bad driver. I want to take all that data, and I want to apply a classification to it, a driving style, and look at how the thing moves around from the information passed in the Internet of Things devices that we plugged into the car, and develop a model around Scott Guthrie's driving style. So here, I can bring in from HD Insight, from vehicle specifications, from relational data, and build this model and see if we can prove mathematically, beyond a shadow of a doubt, that this is a problem. And then I can go down here and evaluate the model and save the data set at any point. So we saved off this data set, and we can put this information. I can save that one, or this convert to CSV. And then let's switch back over here, and I'm going to show you the result of that data set. So I'm going to run this store app. This is the one that Nicole was running earlier. And there's Scott. I don't drive around as much as Scott does. I think what happens is that the chauffeur comes in, he shows him his ID, and he just shoves the chauffeur away, and then Guthrie's driving the car, and it's just a nightmare taxi ride. Here, that driving style is the model that pops out of the machine learning. So we can see his aggressiveness, but no breakdowns. So a very reliable car if an aggressive driver. We can see all those different things and look at the ratings over time. I can click back and look at the car itself, and then this data is coming out cleaned and developed in my model. I can look at the rides, the alarms, all within my application here, and even dig in. So once you get that big picture about how someone drives, how something moves, asking the hard questions, you can also drill in. Well, where were you on October 8th? Let's see where you drove the car on October 8th. Okay, you went on the Long Island Expressway. Why did you go that way? Let's look at the traffic, and we can zoom in and figure out what's going on at that particular moment. Plugging those things in, being a full-stack integrator is what I find to be just kind of so joyous and exciting about this, and why I enjoy building things like this so much. So what I want to show you now is that you can see we've got this great budget, and they bought me this thing, which is exciting. But I wanted a car, and they didn't give me a car. They gave me a Metro Pass. I mean, it was generous, but still. So I needed a car, so I used some funds that I had, a little bit of a slush fund, and I bought a car. And I put the Internet of Things stuff on the car. So here's a Fez Raptor and a battery pack and all the different sensors that describe what's going on in this particular car. So this is a simulation of the boss on his drive. Okay? So I put that down here. And what we can do is you see here on the screen, waiting for the driver. Well, the driver badges in with their badge. So I'm going to come in here and just tap that, and then there was Scott Guthrie on the car there. He badged in, so now there he is, see? And I'm going to drive this car around, and hey, there you go. So this is, Guthrie doing his thing. Hey, I work at Azure, it's great. So we get all that information and all that accelerometer information, and we can act on it immediately with events. Clearly, we'll have to send help, later, but we can also analyze things over time. So you get that real-time experience, you get that powerful, huge data modeling experience, and the ability to do things that were just not even conceivable before. It's such a joy to work with, and it makes me very happy to share it with you all. And the thing that I'm excited about is just the idea that it's not an all or nothing proposition, right? You don't have to buy into Azure and time to move everything to Azure. You can have connections. You can have some things in Azure and some things on premises. You can plug in and use the pieces that you want, and when you're done with it, shut it off at night. And it's so significant that the pieces are plugging together in this amazing way. It's happening. I mean, I can't believe that Miguel and I were up here to share this with you. We've got an open platform. We've got a great cloud with open SDKs that lets you run anything that you want, any way that you want. We now have a SKU of Visual Studio that's going to allow you to do whatever you want with this platform. Powerful, flexible, and open. And frankly, I just can't wait to see what you all are going to build with it. And thanks so much for letting me share that with you today.
Our customers are in the business of selling units, motorcycles, boats, ATVs. The goal of DX1 is to be a single solution for a dealership.
One solution, one system to solve all of the operational and marketing needs for a dealership. The market is getting more competitive. Everybody is looking for an edge. The cloud infrastructure allows us to innovate more rapidly. So we release features faster.
That we're cloud-based means dealerships don't have to have anybody on staff to manage servers. It really is a win-win for them.
It's not location specific. We can just log in anytime, anywhere, and so can our users.
Azure will scale for us on an as-needed basis, so we're only paying for what we use.
Having everything in one place with Visual Studio Online really enables us to collaborate and work better as a team.
We have team members in Thailand, Minsk, Virginia, Canada, in addition to here in California.
You're spending less resources, you're spending less time, the customers are happier, the turnover is reduced. This is perfect.
It's key for us to be able to deploy at any given time. We get updates to Visual Studio Online in a seamless manner that allows us to be efficient and improve our own process constantly.
We've seen a huge benefit of application insights, the ability to see what's behind the scenes, what customers are doing.
With Visual Studio Online and Application Insights, we're able to look at a single screen that shows us that performance without having to debug any deeper. We see full call stack resolution in our output, and that really helps developers to determine where exactly the performance is being lost.
The developers can just take one look at the screenshot that we've taken or of the link that we've given to them, and they can understand right off the bat what the problem is.
Visual Studio Online and Azure has given us advantage because DX1 would not be possible without it. We're skating where the puck is going to be. We see it absolutely as a big part of our success.